determine whether the relation is a function and explain. Remember, we're looking at the x's and the y's to see if every item has the same price. So you'll notice -2 is $7, 2 is $7, 5 is $7, 8 is $7. So every input has exactly one output. It's okay that these inputs have the same output as long as there are not two x's listed the same that have different outputs. So anyway, it's going to be yes, and it is because every input has exactly one output. And again, it was just kind of like the dollar menu example where it's okay for them all to have a 7. Okay, number 34, determine whether the relation is a function and explain. Well, if we have a graph, it's easiest to do the vertical line test, and I'm just going to draw one vertical line, and notice that vertical line passes through 1, 2, 3, 4 times, so definitely a no on this one. It does not pass the vertical line test. The vertical line, remember, is only allowed to pass through the relation one time. Number 35, find the domain and range of the function represented by the graph. Is the domain discrete or continuous? All right, so first of all, we're going to look at the domain. Remember, the domain is the x's and the range is the y's. And so this time it's connected. We're going to be looking at this a little bit. So if I'm looking like from left to the right, so the farthest to the left the graph goes, to the farthest to the right the graph goes. So we're looking this way. So what's the furthest to the left it goes? The furthest to the left it goes is -3, and the furthest to the right that it goes is 2. So the way that we're going to write our domain is -3 is less than or equal to x, which is less than or equal to 2. Right? The range, we're going to look at how far down it goes to how far up it goes. So we're looking at this. How far down to how far up. Okay? So how far down? It goes down to -3, and it goes up to, looks like 3. Okay, so our range is going to be -3 is less than or equal to y is less than or equal to 3. Right? Then it says, is the graph discrete or continuous? Well, I don't just see dots on my paper, I see connected dots because it's just a continuous line. So this is going to be a continuous function, and the reason is we could say the dots are connected, even though we can't necessarily see dots. Or I could say all values are included because we don't just have dots, disconnected dots. They are connected. Okay, number 36, draw a graph plotting time versus depth of water to model the description below. Well, before I even model the description, I'm going to go ahead and get my graph ready. It says we're graphing time versus depth of water. Okay, all right, so it tells us the plug is put in the bath. The tap is turned on, then off. Hugo gets in. Hugo's larger brother Tom gets in. Hugo and Tom play with their toys. Hugo gets out. The plug is pulled out, but Tom keeps playing. So I'm going to put several things. The plug is put in the bath, so maybe that's a 1. The tap is turned on and then off. Hugo gets in. Hugo's larger brother Tom gets in. Hugo and Tom play with their toys. Hugo gets out. The plug is pulled out, but Tom keeps playing. Okay, so basically we have 8 different things going on in the bath. Okay, the plug is put in the bath. So if we put the plug in the bath, until we put the plug in the bath, there's not going to be any water in the tub. So that's going to be 1. Okay, then the tap is turned on. So if the tap is turned on, the water is going to start getting into the tub. Okay, then the tap is turned off. So now the tap is turned off. So no more water is going to get put in the tub. Then Hugo gets in. Well, what happens when Hugo gets in? The depth of the water is going to get bigger because it's of the displacement. Okay, so Hugo gets in, and then Hugo's larger brother Tom gets in, so it's going to go up even more. And then Hugo and Tom play with their toys. So the depth of the water is pretty much going to stay the same, but if they're playing with their toys, I'm guessing there's some splashing going on, so it might be going up and down a little bit. And then Hugo gets out. Well, if Hugo gets out, the water level is going to go down again. And then the plug is pulled out, but Tom keeps playing. So the plug is pulled out. eventually it's going to go back down to being no water. So your graph should look something like that. Okay, number 37, evaluate the function when f of 8, or we could say when x equals 8, that's kind of weird wording. So we have f of x equals 3/4 x minus 2. So wherever we see an x, we will put an 8. So we'll have f of 8 equals 3/4 times 8 minus 2. So then we'll have 3/4 times 8 is 6, minus 2 is 4. So my answer would be 4. Number 38, Girl Scout cookies are 50 calories each. The total calories consumed, C of x, C is a function of the number of cookies you eat, E, right? Independent variable and dependent variable. Okay, independent variable, we get to pick and control. I get to control the number of cookies that I eat. So E will be the independent variable. The dependent variable depends on how many cookies I eat. So the calories depend, number of calories depends on how many cookies I eat. So that would be C. And then is this discrete or continuous, and explain. Could I eat a fraction or a real decimal number of cookies? Well, pretty much we're going to eat, I'm going to say discrete, because we might eat a half a cookie, but we definitely we wouldn't eat an eighth or 0.25 or 0.16 of a cookie. So it's going to be discrete. We'll basically just eat. So the explanation would basically be, although we can eat a part of a fraction of a cookie, we really wouldn't eat decimal of a cookie. Hey, Joel.